Welcome, everyone, to Omaha Data Science Academy. This is Jeremy Bergman, teaching the class Cloud. I always forget the name of the class, but Cloud Data Engineering and API Integration. And I just butchered that too. Cloud Solutions and API Integrations. This is Jeremy Bergman for the instructor in Omaha Data Science Academy. Tonight's lecture is lecture number 6 in this class about cloud-based machine learning services and MLOps, so machine learning operations. This is all about the different available cloud-based machine learning services, what's available to you as far as platform as a service. Like we've seen in class, some of the platforms like Azure Machine Learning Lab, Google Colab, those type of platforms that give you the ability to be able to create and manage and maintain your own machine learning models. Tonight we'll evaluate Dataiku as that machine learning SaaS platform, but also machine learning services, so software as a services. So pre-built models that you can let's go out and connect to programmatically. Maybe it's OpenAI ChatGPT 4.0 model. You could go out and programmatically connect to it and use it in your applications without having to develop your own large language model. So that's often software as a service, is that a model will be served via REST API or some other API, potentially, be a programmatic API for you to use instead of building your own model. And we'll cover some of that too. And along with MLOps. So MLOps is machine learning, how you manage the machine learning life cycle all the way from beginning to end. So how do you manage data? How do you build models? How do you deploy and monitor and iteratively update these models? They'll be cover best practices and best practices of ML, like what is MLOps, best practices, and some of the key principles of it, and then putting it all into action within Dataiku, within a actual platform as a service like Dataiku. Yeah. So how is this class structured? That first hour, we're going to let's introduce ourselves as different machine learning services and APIs, platform as a service, software as a service, model management lifecycle. So you probably likely covered this in your machine learning classes, but the different phases all the way from understanding the problem, gathering the data, cleaning the data, then and summarizing it for analysis, then building those models, evaluation, deployment, and then iterative improvement. So how do you do that in the framework of machine learning ops engineering principles? So they go hand in hand together. It's a model management lifecycle, and it dictates, or it at least points to, what are the key machine learning operations principles that you would use as a data engineer. So in hour 2, we'll start to get familiar with Dataiku. So we'll have an introduction into Dataiku in the second hour. And then we'll get our hands on it. We'll start working with it, understanding platform architecture and key components. We'll build models within it. We'll look at how we can manage models and deploy models within the environment too. So similar to the other platforms that we've learned about, cloud platforms, it's a collaborative environment where it allows data scientists and engineers and analysts all come together. It has the architecture for that and the different components. You'll see that a lot of the components here are very similar to things that we've already learned about in this class in Azure or within Azure Databricks or within Azure in general. Ability to build models, manage and deploy are also key features of any platform as a service. And then we'll do a hands-on exercise of building and deploying basic machine learning model using Dataiku and overall market cap crypto data. Okay. So that's how it's structured. Quick overview. Some machine learning and AI services, platforms as a service, how do you build models and manage and deploy them, and what are some already pre-existing services and APIs that you could potentially utilize and connect to without having to build your own models. So Azure has AI and ML services. Instead, in this class, we're going to learn more about Dataiku. So we'll learn more about Dataiku instead of Azure Machine Learning, and Dataiku's components and workflow, and then how do you build models and deploy them within the platform also. And then we'll do some hands-on exercises. So instead of Azure AI and ML services, we'll use Dataiku for this lecture. Okay, so what are these machine learning and AI services? We have talked about it a little bit here in class, especially right at the beginning of platform as a service or software as a service. But machine learning and artificial intelligence services, they encompass a large range of cloud-based platforms and tools that allow individuals and organizations to implement, manage, and deploy models. They're designed to streamline processes associated with developing AI applications, from data handling, model training, to deployment and monitoring. So really the difference is, are you building your own model? So a platform as a service, it'd be able to give you the ability to store data, connect the data, and then tools to be able to build models, deploy models, and manage and deploy models. So in a way, a platform helps you with building your own models, but software as a service also helps you in just complete automation where you don't even have to build your own models. You have pre-trained models. An example would be Google Cloud API. They'd have existing vision APIs for vision of image recognition. Self-driving cars is always the one that I like to think about when using vision API, but that could be any type of picture. You have your speech APIs, so speech to text is something that's common. Natural language API would be a lot like your large language model. You would feed it into a document, or feed it a document or some unstructured data. It could potentially clean it up for analysis and summarize. Sometimes will also classify documents. Depends on what you're trying to do with it. And translate API is what you think. So you translate from one language to another. So Google has this app you can use. It works okay if you're practicing a language or something like that. And now you actually have apps that you can go out to, like Duolingo, or I was trying to think of the one that is directly conversational. There are all sorts of ads for it, but I'll think about it. It'll pop out into my head here in a second, but basically, instead of having to train it on all sorts of data and then refine the models, and times you're doing reinforcement learning, so saying if something is right or wrong, these things are already built for you, so it already has a large head start. My tendency would be to see if there's any existing models that you could utilize for your purpose, as opposed to building your own. Because if you build your own, then you have the whole life cycle that you have to manage. Whereas if you have these existing API or AI models or machine learning models already created, they'll continue to update and improve those models. So it's something that they'll completely manage for you, which is a good part of the cloud or programmatic services. Is like you don't have to do all the work to manage all that data or manage those services. They have managed services for you. So this one would actually be mislabeled there. This would be, no, that's right, software and platform as a service. Nice, we're going crazy. Okay, so just a brief overview of those different types of machine learning and AI services. They'll be focusing the rest of the night on platform as a service. So if you're creating your own models, what's the platform that you can use to manage machine learning model from end to end and create your own machine learning models and managing them from end to end. And you can see those platforms already have a lot of those tools built in. If you're using Databricks, then you'll have everything at your hands. If you have big data processing or real-time streaming data, or just want to create a model through a Databricks notebook, you'll have the People collaborative platform, highly integrated with storage and compute. And then you could feed these and deploy these out to other applications. Okay. So AI model management lifecycle. This is important if you start to manage your own machine learning models or predictive machine learning models or AI. They all really follow this framework within the life cycle of both the initial life cycle, the first iteration of a model, and like I always say with models or data, the work is really never done because there's always new data that's coming in that'll allow you to create new insights or gain new information or make better predictions. If it's a case of a predictive model or machine learning model or AI, there's always new data coming in that'll help you improve the quality of the information and the quality and relevancy of those models. So lifecycle model, it provides a framework for this. There's also another framework that I always use. It's called CRISP-DM. I'll briefly skip to that here at the end of this as an appendix. But there is an appendix B on CRISP-DM methodology that explains each one of these steps in the framework. So if you're interested in learning more, there's more detail into each step, from understanding the data preparation to model building, testing and evaluation, and so forth. But just want to cover it real quick and provide that, just point to that as some deeper detail on this management lifecycle. So this doesn't actually include business understanding. Business understanding may be the most important part of the entire management lifecycle. So ideal is anytime you're in data and you're trying to solve a problem, understanding the problem and issue as thoroughly as possible helps you come a little bit closer to what the right solution is, even if you have to iterate on it later. As if you don't understand the challenge, likely you may understand the data and you may build a model, but that model may not be something that actually helps solve like that business challenge, having the business understanding of it. So this is often where data scientist comes in to help understand the challenge, and engineers work with them along the way to help get the data they need. Data scientists will often do the testing and evaluation, and data engineers will collaborate. with the data scientist on deployment out to business operations. But really, they're helping them along the way in this management lifecycle, but just highlighting where each key component or where each role would be most active in this, but a collaborative effort between the two. So data preparation, so business understanding, that's often the data scientist, but data engineer would it help them to understand the business challenge too. So the data scientist builds the right model and the data engineer helps them to deploy the right solution and the right context for it. So even if a model kind of solves a problem, you have to get it in somebody's hands to be able to action on it. So having that business understanding, a data engineer to help with deploying it in the right way is one of the parts of this also. So the other steps will be data preparation and data understanding. So understanding the data that you're using to prepare it the way you need to build the model, all based on the business understanding. I think these really go hand in hand a lot. That's why you have a back and forth arrow. But once you get that real data understanding and business understanding, then data preparation and model. You have your data preparation and model building after that. So then you do model training, your model building, model training, and you're training a model, usually creating multiple models to see which one performs the best and relative to each other and which one you want to use to be able to solve the problem. Then you evaluate the model, the performance. That's part of deciding which model you want to use. You test it to see if you believe the model will hold. Deployment is where you put that into real world use. One of the, like I've said a couple of times already, actually getting it out there for its intended purposes to solve that business problem or challenge. And then the last one, it's not part of this, but there's a continual monitoring and continuous improvement. I'd actually probably see that as like this blue line on the outside. Often after you deploy it, you're going to go back and evaluate it a little bit later to see how it's doing and how people are using it, or if the predictions still hold. And then maybe the business challenge has now changed. So, or the data profile may have changed, or maybe new data that you have to understand that's coming in. Especially after you have a model and people start actioning on that will change the data profile likely considerably. And then it's back through the same, understanding the new environment, preparing data, updating the model often, maybe building new models and seeing which ones performs the best, testing them and then deploying it, and then doing it all over again, continuously all over again. When I've been in business or when I've been in roles where we deployed predictive models or build and deployed predictive models, usually this was on some type of time frame. We would decide what type of model it was and how we felt about its predictive accuracy and the amount of risk that it had. So maybe some models you build are riskier than others. So maybe, a large language model may not be a big deal if it's just helping someone with their job, but maybe it would be more of a big deal if it's trying to help with emergency situations where these predictive models are doing something that's like a very critical process within the business. And it needs to make sure that the predictions stay consistent. Otherwise, there may be a lot of risk involved. Or maybe the model just isn't great and you decide like it's kind of a risky model, but we think it works. We need to model it, or we need to monitor it like every week to see how it does. see, make sure that it actually holds up. And then trying to continuously improve it with new data. Also, some of the insights that you gain from just monitoring it will help with continuous improvement and that continued understanding. So once you build a model, it's never done. It's actually would be kind of dangerous to build a model and then never look at it again, to just let it keep running. One of the things is just making sure it's making predictions as intended and it's being used as you'd intend. Both data scientists and data engineers' job to collaborate on that. So wanted to give a thorough discussion of that because the tools within cloud-based machine learning services, particularly platform, are built around the idea of these different model management life cycles and then being able to monitor and continuously improve your models. Okay. So that brings us into machine learning ops. Machine learning ops is connected to that model, to the model management life cycle. And now this is like taking it and discussing how, as a data engineer, you develop some type of application to be able to manage the model life cycle, the model management life cycle. So what are the key components of machine learning ops for a data engineering perspective? So building pipelines to be able to automate, automated testing and deployment. If that sounds familiar, we'll see in a second. If you've worked as a developer at any point, you will see a lot of similarities between that. The key difference being data, and between machine learning ops and being a developer or DevOps. You'll see it in a second, but there are a lot of similarities, like maintaining pipelines to the testing and continuously deploying new updates. But they'll have some unique things here too, like being able to reproduce data and results. Similar to developers, they'll have continuous integration and delivery, and they'll continue to want to monitor those new integrations and deliveries that they create. So similar between regular developers and data engineers. Data engineers and data scientists will focus on model performance and potentially data drift. So how is the data changing that you're using for the model? And then governance. You could have governance in both too, but mostly focused around data with machine learning operations. So why does it matter? Reduces the gap between research and production. It helps to have experts, especially if you're in a bigger organization and can afford it. It can help allow the data scientists to be data scientists and the data engineers to be data engineers, and then work potentially with DevOps teams or other tech teams to be able to put these models into operation or production. So it enables faster model iterations and deployments through automation or just improved processes and technical ability. Improves model quality and reliability. So instead of having, a lot of this has to do with maybe not having data scientists do it, having a robust and a process or infrastructure to ensure that your model quality and data quality and reliability all stay up to par or where it needs to be. Ensures operational efficiency at scale. So one of the data engineers' jobs is to understand how to scale data solutions. That's why MLOps matters. And then provides clear audit trails and governance. So Sure, when you make updates to the models or make updates to the data, you can track those and that they're of high quality. So what this graph shows, or this graphic shows, and how you go from development to operations. So this is like really like MLOps and deployment. So you're planning for deployment, you design that model and create data scientists do that. So like what's your initial plan or business understanding for deployment? Got rid of sneeze. Bless me. So how do you plan your initial plan for deployment, then creating a model and design? We're creating the model and exploring the data. You're like designing that model for deployment. And the plan comes from your business understanding. How do you think you're going to deploy it? Then you build that model, and then you build the pipelines that will be able to manage that model. You also test these pipelines. And once you built and tested, then you can deliver it into operations. So oftentimes now it's by REST API, or maybe it's by some other type of integration, maybe direct connection to a database if you're internal in an organization. But now you're continuously delivering it in continuous integration with your operation teams or your operation systems. So this is like where it becomes really critical that all of the work that you've done here makes for good model and predictions. So you have that continuous integration pipelines that you built. You deploy your models out so people can use them. You manage and operate the model, so continuing to look at the performance and how you can continue, how you can improve maybe its deployment performance, or how you can improve those models. You monitor and track those key metrics, so a lot of predictive accuracy, but perhaps it's also usage or monitoring, tracking, usage or predictive accuracy or other things that you would like to track. And then you do it, continue to do it all over again. So once you see those, you monitor it, you come up with another plan for deployment, and it's continuous. So MLOps is a key role for data engineers. And sorry, oh yeah, Luke, that was from earlier. I was going to say, sorry, I said I was going to keep up on all the comments, but that one was from earlier. So we're still good. All right. So what is MLOps? So understanding MLOps and data engineers' role in deploying solutions. So what are the key principles of machine learning ops? So we understand the role of machine learning engineers, or data engineers and the role of them in machine learning ops and the model management lifecycle. So what are some of the key principles of MLOps, or what important principles there are to data engineers who deploy machine learning models and other data products? So being able to reproduce results, so not even just for machine learning, but being able to reproduce historical results from data or historical analysis, and storing that data and processing the data in the way you need. Even outside of doing that for machine learning, whether it's just for business purposes, is like one of the absolute key rules for a data engineer. So being able to consistently do model training for machine learning, or consistently being able to do historical analysis from data analyst point of view. Engineer helps enable that. So getting the right environments, version controls, managing lineage and stuff like that, being able to reproduce it through pipelines. It's a huge part of MLOps and data engineering. Automation is huge, so being able to manage things at scale. So automated data validation, pipelines, testing, continuous integration, and workflow orchestration is like after you create these pipelines, the order sequence that they need to run or the times of the day they need to run. Being able to do that in an automated fashion is huge when you talk about being able to manage data at scale. But you also have monitoring, so being able to model or monitor performance tracking against key metrics, seeing when data changes to be able to identify the things that you may need to adjust in your models or analysis, how your resources are doing, and service health. So if you deploy API endpoint, making sure that's staying available. And then resource utilization. So the systems that you're operating, making sure that they're in good health for your users. You also have governance. Data engineers have a big part in that. We won't talk a whole lot about it in this class, but governance is really like making sure the right access controls are on data for different users, or the right business rules are applied, audit trails, data remains highest quality, has documentation so people are using it, and if exciting stuff like that, I guess. And then explainability tools to be able to like know what models are doing and the predictions that they're making and so forth. So governance can be is like oftentimes its own part of a bigger organization. And then being able to collaborate, a collaborative platform and environment fostered by data engineers. So being able to do cross-functional teams, creating workflows for different users and so forth. Like I said at the beginning when I was talking about reproducibility, not just for machine learning models, I would say that these are data engineering roles in general to help with the reproduction of data, monitoring it to make sure it's the highest quality and it's what everyone needs, and having collaboration and governance. Those sort of two go together. And definitely one of them is automating data and data pipelines and being able to do it at scale, or just general data principles for engineers. And then on top of it, machine learning ops principles. So when you're building models, these principles still apply. Infrastructure. So MLOps is infrastructure, often provided by platform as a service. All of these things are going to look, they're all going to look like things that we learned about the data infrastructure so far in this class. So data lakes and warehouses, having things like versioning, like we originally learned about Delta Lake, feature stores, so that's to machine learning operations itself. So being able to see model changes and feature management there. Data catalogs, data quality. We don't cover it in this class, but Azure does have those capabilities. And then being able to monitor data quality. So often these platforms will have development infrastructure. We saw that with things like Jupyter Notebooks or your distributed platforms or different NoSQL tools, databases, and so forth. Being able to track your experiments, which is just another word for your model tracking. And each time you run a model, it's an experiment. I mean, version control of your code, containerization, and compute resources. So within this environment, having an environment to be able to contain your code. Sometimes you would set up Docker for people to do their own custom code. In our platforms, we've seen where you can just do notebooks within these environments, and then setting compute resources. Then you have your operations infrastructure, so your pipelines, continuous improvement, continuous deployment pipelines, orchestrating workflows, creating API endpoints, and then the ability to be able to monitor performance, your data profiles, and logs and tracing for be able to track what's happening within your data systems. Right. Well, I briefly mentioned it, but comparing machine learning operations versus development ops. So if you've been in a professional development environment, you may hear DevOps. Basically, those are software developers and what types of processes they use to be able to continually deploy perhaps its new features to a website or application. More and more development is moving to a continuous integration and continuous development pipeline because or methodology in pipelines because those changes happen much faster instead of very slowly by deployments and processes behind the scenes. So people like the speed to I wouldn't say speed to market, but the speed to production of new features, and then being able to monitor it. And even if it's not perfect, you can get it out there and start using it and then continue to improve on it. So a lot of similarities there. Automation for workflows and pipelines. Of trying to automate as many processes as possible to be able to do things at scale, collaboration, version control, and monitoring of systems. So in development and maybe deployments, and then seeing the performance of how things do, how a new change does, or how the system performs after the deployment. Same with machine learning operations. So they have some extended, however, there's still extended requirements for machine learning. So a lot of it's related to data. Specific to machine learning, it's feature stores to be able to do feature engineering for machine learning models, to be able to keep track of those changes and actually being able to engineer those. Experiment trackings for changes in models that were deployed, registering models, and then being able to detect changes in the data. So really a lot of similarities other than machine learning ops and data engineers are working with data and things that are specific to the deployment and integration and updating of data-related applications, or I like to call them data-related products, whether it's dashboards or reports or things like machine learning or AI models. I listed the key differences. What are the primary artifacts? So what are developers working with as opposed to machine learning? Developers or data engineers. They both have testing focus, but their testing focus is a little bit different on what developers are testing versus data with machine learning or data engineers and MLOps. How you deploy new models and changes to a website, which would be like code commits versus, new models, retraining a model and deploying them by REST API. Different type of versioning needs, being able to monitor some similarities in monitoring system health, but now you're doing models instead. And then who are your stakeholders? So stakeholders are often operations, business management with new features within their systems, or maybe these are customers. And I'd say it's somewhat similar for machine learning because you have your customers or people you're deploying to in operations, but they're also stakeholders like data scientists machine learning engineers, which are kind of like data scientists, maybe data analysts and so forth. So maybe slightly different stakeholders and with different needs. So a ton of similarities. I would say sometimes your professional developers do well at transitioning over to being data engineers and machine learning and doing like machine learning and AI, but not always. They're developers that oftentimes they don't really have they don't have understanding of the data. They're more like functional programmers, which is just fine. And they understand the systems from functional standpoint. But doing machine learning operations and moving to data engineers is really about data and understanding data and deploying those type of solutions and products instead of pure functionality. So I would say the skill sets are really similar, but it takes a little bit of a different mindset for machine learning, and in particular a data mindset to do machine learning operations or become a data engineer. Happy to have more discussions about that. It's something I've thought a lot about myself, but if you're looking to move over from being a developer to machine or data engineering, happy to have that discussion with you and thinking about some of the things to think about as you do it. Right. So we're going to do just 2 more slides here and then go to break, and then I'll have a video. So having talked about that's the life cycle and machine learning ops and those that whole life cycle, model management life cycle, and DevOps and the role of data engineer. So as a quick introduction to data, Daiku's Data Science Studio. So as all of these platforms as a service, they promise, is bringing data analysts and engineers and scientists together. So it's a collaborative environment that multiple roles can use, because really, like, I think of data, it's really collaborative between a lot of different people, especially in a big organization, to understand the data, to being able to build models, people who understand the systems and data, I should say, people who build models, people who know, development and other systems, tech systems, being able to deploy it, and then your business owners, so often like your management and people, and then your business users, the people who are using them. So it's huge, often a big amount of people who are impacted or have some type of role in it, and having a platform like this, especially if you're in a bigger organization, is something that can bring them all together, and a lot of what these platforms as a service promise. One of the things Dataiku uniquely talks about is enabling self-service analytics. So this visual interface that can be created to load data, to be able to prepare it in different steps, and create your model building and dashboards around it. Being able to easily connect to those data sources. So if a data engineer creates a new data source, then data scientists and data analysts can just go ahead and use it and create it in workflows or any other needs that they need in the platform. And it operationalizes machine learning. We talked about in this class an end-to-end data product, all the way from gathering and understanding the data from different systems or sources, all the way through all those steps up to deployment. So Dataiku has that as an end-to-end ML workflow. So it has model versioning, monitoring, and governance features even after it's deployed. So even the continuous improvement and continuous delivery. automated retraining, so automation. You can integrate it with existing cloud infrastructure. So with our project, we'll connect it to Azure Data Source, Azure Data Warehouse, and it has any number of other systems it can connect with or integrations, and those build in MLOps capabilities. So really similar to what we've seen before, kind of a nice interface, specifically geared for data analysts and data scientists. And data analysts, data scientists, and data engineers, all to be able to easily work as one within a cohesive platform in the cloud. Okay. Capabilities. I copied and pasted the same image, but that's okay. So their slogan, like we talked about, is bringing data scientists, analysts, and engineers together. We'll take a look at the platform architecture and key components. They have the ability to manage projects, visual interfaces, and version control through Git. If that sounds familiar, it is, because similar features within an architecture within Azure. You can build machine learning pipelines, visual prep and data recipes, code transformations, Python integrations, visual analysis, and model building. So you can all do this in Azure too. And you like in Azure, it's a little bit in different spots. So maybe you do visual prep and data within Azure Data Factory. You do your code transformations and Python integrations. Maybe you're doing that within Synapse Analytics, and then you do visual analysis in Power BI with model building in Azure Machine Learning Lab. Whereas this, I thought it was a good choice for the class, because instead of having to piece together all those components, now a lot of it's here. So we will use Azure for the first part of it, but now you don't have to piece together like Azure Machine Learning Lab with it. It's already built into this platform. And you can do versioning, you can scale this environment also if you need. You can make a virtual machine that's scaled up and down. You can choose different model deployment options. You can automate these workflows and schedule these workflows and monitor and maintain them also. So like I was saying with Azure, it sometimes still feels, even though it's a cohesive platform, that we're still putting together the multiple pieces, especially in just your regular Azure data services. What is a little bit different about the other Azure platform that I taught the last time, which is Microsoft Fabric. Fabric is like that woven, they call it Fabric because it's like that woven platform where it takes all these technologies and tries to be a little bit more like this. And it does an okay job with it. It's just not quite as mature as this product is, or easy to use. This is really where these platforms are headed. And I'll have to try the Google platform, like Colab and Google. I imagine it's very similar to this. And I think people have used that in their other classes. Might be an option that we do in some of these future classes. If anybody has feedback on using Google Colab, please, and their experience with it, please let me know. You'll likely see a lot of similarities between these platforms, and I'm interested to hear more about it. All right. So we will go to break. We will come back at 7:30. This video is 12 minutes long, but it takes you start to finish, like what the entire workflow, MLOps workflow looks like in Dataiku. Plus, it'll take you through different menus and options and so forth. Really like the usability and the end-to-end process of machine learning model in Dataiku. So I'll go ahead, paste this in my browser. Get this link out of here. I can find it. Here we go. Copy video URL. So I'm going to put this in. This is an end-to-end demo. End-to-end Dataiku demo. Okay, I just pasted the link here in Slack. Provide a pretty good demo, 12 minutes long. We'll come back at 7:30. Finish up talking about the components, and then start doing hands-on exercise with Dataiku. So doing well on pace today as far as getting to our working demo and working within Dataiku. So we'll do this. Go ahead and watch that video over the next 12 minutes. I'm going to get up and grab something to drink as usual. And I will be right back to discuss at 7:30. All right. Enjoy the video, and we'll start again then. See you in a few. Okay, we'll give everyone another minute or two to digest, or whether it's that content or maybe grabbed a couple pieces of pizza and scarfed them down. Digest either way. Then I have a couple of thoughts on it. It's definitely, I haven't used Dataiku in a little while, but it's definitely a sweet platform now. I'm very, very impressed. Let's give everyone 2 minutes to finish up. Right, just a few more seconds. I did want to give everyone a link. The link in here. 7 platforms of these platforms as a service that you may be interested in utilizing, whether it's Azure ML Studio or Amazon SageMaker for machine learning and AI models. There's 7 of them, and they give them a review. And with one of them being Dataiku, I would say it's Dataiku is one of the leaders outside of IBM or Azure or SageMaker. Watson, not quite so much anymore. I'd be interested. I haven't used it in a while. Interesting that they don't mention Google Colab. I guess Google Colab is really the Jupyter Notebook part of it. I think it's called Google's. I haven't used Google in a little while either. So what is Google's has? They just call Google AI. What is?
You mean Gemini?
Is it Gemini? That sounds right. I knew it somewhere. It's like on the tip of my tongue.
They also do the notebook LM thing, but that's not their core.
Well, Gemini is like the LLM.
Oh, or just maybe Google Cloud.
I know I did a Google Cloud or the Google Cloud class a while ago. It's like during the pandemic when I didn't have anything else to do. And they have a model builder lab inside of it that's like that I thought was pretty decent at the time. Was Google's
Vertex? Or AI Studio? Vertex?
Felt like it's called Lab or something like that. I hate Google. Why do I keep doing a Google search? Let's see. We'll use ChatGPT for this one. feel like Google has become less and less relevant, like relevant results. It's a bunch of crap.
Well, it's fragmenting, kind of like Amazon. It's difficult to figure out which one you want.
What's that?
I said it's kind of fragmenting like Amazon. It's getting complicated. But what about Vertex? There's the Vertex AI Studio from Google.
Yeah, that's what comes up for model building. I have not used Vertex yet. That or it's rebranded at some point in the last 5 years, which is very likely. It has an auto ML for tracking different changes to your machine learning model. BigQuery. And BigQuery is like Google's. It's like a combination of what we saw is where you could query SQL into the data lake with Azure Synapse Analytics, but it also handles real-time and streaming data. It's actually kind of nicer. That's a pretty nice feature of Google. It's BigQuery. I'm going to take a quick look since we have a little bit of time. Let's look at Vertex. I just do a couple, see if there's like a quick 3-minute demo. I guess I won't run it either because nobody else has sound. I'll run it a little bit later. Vertex AI demo. All these are a little bit longer. Do you remember they have the whole series of Google product managers who help you with their products or do the classes? Here we do. We'll save this for after class. Let's see. But I am very interested in taking a look at it. But, all right, so anyway, my key takeaways from, at least mine, my key takeaways from Dataiku is that Dataiku is actually really nice. It's improved quite a bit. I haven't used it in a couple years either. But you can see how aligned that cloud platform is with MLOps and the AI and ML model lifecycle, management lifecycle, all the way from managing and preparing data to like deployment, and then they have tools for monitoring and continuous improvement and like putting out those dashboards and monitoring API health. Also, you saw that it was highly integrated with the other platforms. So not only just like a platform to be able to build your own machine learning models, but they were bringing in like different OpenAI LLM models in to do different things. So they were actually like integrating those into their processes on top of it. And then connecting to like REST API is easy to bring in other data. So it's like, it's not exclusive to building your own. You could potentially connect to a REST API and make that just, or I mean, a existing machine learning or API, machine learning or AI REST API model or some other model and integrate that as part of your workflow and then deploy it directly. So it gives you a platform for that also. I mean, so does Azure, but I really found that platform to be nice, this platform to be nice and easy to use specifically for machine learning purposes, machine learning and AI purposes. Now, if you're going just more of the route of business intelligence and data lake and managing and transforming a lot of data, that Azure or AWS might be a better tool than Dataiku. But specifically for model building, it doesn't get too much. I didn't think that it doesn't get too much better than what I saw in Dataiku. Now that was like their sales presentation, so I might have got a little dove-eyed from it. But very easy to use, and it was super simple to deploy a model. It's not so simple in Azure. So I'm glad for the sake of time that we moved over to Dataiku to help everyone out and get through this project. I had one more point. I forgot what it was. So if I remember it, I'll come back to it. But we'll get through this and start creating our models. So I probably could have done this slide, the components right before this. But the main components of Dataiku and workflow are your data sets. So that's your collection of data used for your machine learning models in Dataiku. You have projects, so that's a container for all related work. So maybe your project is a machine learning application. You'd have your data sets and your models and flows and recipes all in those projects. Oops. Of course, you have your models. Those are your trained models. You have that flow, which is that pipeline, these pipelines that we saw that are created in Dataiku with these different recipes and transformations and so forth. Your recipes, yeah. Oh, sorry. Recipes are your transformations, like I just mentioned, applied to your data sets. You can stack those upon each other. And then your notebooks and dashboards, same thing that you saw with Spark and those notebooks in Azure. They're right there in Dataiku also. So you have an interactive coding environment. And then you have also built-in dashboards that you could use for visualizing data and monitoring. So one of the other points I really liked about that is Dataiku is when you import data, there's a very nice visual interface in there that tells you like a bit about data quality. So when you load up the data, like how many missing values are there, how many values are there in total, and so forth, that help you then do your transformations on the data set in multiple steps. So I'd say it's pretty highly really like a nice platform for people to for collaboration on these machine learning and AI models in particular. Right. Yeah, I think the biggest reason CAN has moved away from it is that a lot of organizations have decided to go the Databricks route, and the licensing is a little bit weird with Dataiku. The enterprise licensing is actually pretty expensive for a specific use case, where as Databricks is already like part of the integrated Microsoft stack that a lot of organizations have, and it's like highly available to them, highly integrated and highly available, and lots of people already know Microsoft technologies instead of having this be a specific technology for a specific use case and being kind of expensive at it. But yep, thinking of that. So yeah, Azure has its purposes too. It's just evaluating what's the use case and what's the best tool for the price for that use case. If you're going the machine learning model and AI route and you have some valuable models, perhaps you get the right price and use case for this. So knowing a little bit about technology and being able to talk to I've done a lot of knowing technology and talking to vendors. That can be a big thing as a data engineer also. Then understanding price and technology stack, and then being able to weigh that versus your current needs. So if you're ever assessing new tools, you're able to do that. Okay. Let's go ahead. We had a little bit extra time. Don't want to waste it all. So let's go ahead and work together on a hands-on exercise here, working with Dataiku, DSS, and we'll work to create a simple pipeline from start to finish. So that goes for creating a product, a Dataiku project, data prep, and feature engineering. So we'll load a data set. We'll load that crypto overall data set, and then try to predict future market cap from that data. Then we'll do some data prep, and as we do modeling, we can do feature engineering. We can build ML models using their visual interface. They have nice visual interface, green interface there where you can select a few different models, or you can train it on a few different models, select the best one. Help to understand this pipeline structure, these flows that you create. We'll be able to model, evaluate, and compare those models that we create. We'll be able to manage those, be able to monitor them, build dashboards for the performance, deploy it, and automate those workflows. At the end, if we get a chance, we could also try to connect to that REST API. Might be ambitious, but they give it a shot. Okay. So first, I get everybody logged into Dataiku. So I'm going to give everyone a URL. I just configured all of this myself. And I'll log out. Hopefully this allows, I'm hoping this allows more than one of us to be logged in. So here, if you place this in this IP address in your browser, I'm going to place it in Slack. Go ahead and try to connect to that and let me know. Give me a thumbs up if you're successful. If anybody's successful at doing it or unsuccessful. If you're successful, you will see a page just like this.
I see a page like that.
Okay. So we should be good. So simple username and password is admin and admin. We can all log in with that because I've set up folders for everybody to work in. So go ahead and try to log in with admin as the username and admin as the password, and let me know if that works. I'm hoping I don't have to create a couple different users for this, so that we can all just use that one.
I was able to get in those.
Okay. It's asking me to change my password. I don't have to, right?
Oh, no, it shouldn't. It didn't ask me to change the password, so here, let me log out.
Okay.
So hold on, I'll double check for you to see if I still get that same. So it's admin, ADMIN. Password is admin, ADMIN. Then I click login. Maybe you forgot your password.
Oh, I was able to log in, but then this window showed up asking me, yeah, that one. Wait, no, The one that's asking me to change. It says the password you just used was found in the data breach. So I
Oh,
don't
it's
have to
okay
change.
because it's just
Okay.
username and password, and they're being overly protective here. Google is. But I think that opened a new window, so, or no, it didn't. Ah, that's annoying. Okay. Oh no, yeah, I'm still able to log in, check one of your other windows. I think that opened another window, and then it just went through it. So, and let me know if you can't. Let me know if you still can't get in. So it has a nice like landing homepage. Dataiku does. You can get a tour. They have a bunch of projects that will give you a walkthrough. I'll show you how you can find those. Like what's new, live demos, like an end-to-end video that we just watched, developer's guide, and so forth. But it has projects and your workspaces, and then applications. I believe applications would be like your REST APIs. So Dataiku applications allow you to package and reuse your projects. So the other workspaces allow you to organize and access data-driven insights, and projects contain your specific workflows. So I think your workspaces, it could contain multiple projects based on the same theme. Then you could have those applications that you produce in your workspaces or also. Okay. So if you'll go all the way down, there are two project folders. One is learning. And it took you here. It'll take you to projects. Learning, I just loaded up all these different apps today. They're all tutorial apps. So if you're interested in looking at these anytime over the next, as you're doing your final project, or I have this license for the next 2 weeks. There's quick start guide for AI, data prep, quick starts, specific to manufacturing, even a use case, machine learning quick start, how to do Excel, how to clean up Excel, and then just quick start. So there's a learning folder inside of there. In the other folder, you'll see students. I created one for each student in this class. It's by your email that I have for you for your how you're registered for the class. So it'll be pretty straightforward. You'll notice here. You'll recognize your email address in there. That'll be your workspace. So with admin access, be careful not to delete or overwrite anybody else's project. Just a note on that. But I'm going to work inside of the ODSA example. So if you have for this guided exercise or the hands-on exercise, if you're having a challenge to doing it, you can always peek at this ODSA example. Okay. We'll go ahead and do this. And I'm going to bring up some guided instructions here for the hands-on exercise. So good thing is like, that's what makes it nice that we don't have to configure anything, really. It wasn't even really that hard for me to configure. This is in Azure in a virtual machine. I was able to search it and set it up pretty fast, but it's good that nobody else has to do it because then we just focus on learning. But so far, so what we're going to do for hands-on exercise today is what I talked about. Use that cryptocurrency overall market data, the fact overview history that has these fields. I'm not going to do this one with the API import. I'll leave that for the final project. I'll lay it out tomorrow and then make sure I'm able to do every step in it myself. This one, we're going to use that CSV file and import it. So I'll go ahead and drop the CSV file in here. Class lectures, class project. So it'll be this fact overview history. CSV dataset for Dataiku demo. There we go. Okay. So yeah, we're familiar with this one. We briefly looked at it in the data lake the other day when we queried it from Synapse Analytics. All right. So we'll go ahead and import that data set. You see there are a bunch of sources that we can connect to. What will be nice is during the project, when you set up your SQL data warehouse, you can connect to it using the MySQL MS SQL Server connection. So we can connect to Azure to be able to get to data set or other or other things or like NoSQL connectors, some other cloud storage you could connect to. You can connect to Google Cloud Storage or Gen 2. Import existing data sets or upload your own files. So it has some number of connectors that you could already use. Go ahead and upload the file. Do fact overview history. And this is just really cool is because now you can see like what percentage of each field is empty. Since I did get this, yeah.
It won't let me get the file from the what do you call it? Oh my god. From Slack.
You can get it from where? Slack?
From Slack. Yeah.
Hold on, maybe it's there. Let's see. If you go, I was trying to see how you could download it directly. Does it show? It shows probably like this as a table. If you expand here, then you can go over to the cloud and download. Yeah, Luke is on it. And then that will allow you to download the CSV file. You can open in the containing folder. So I'll give you a second to catch up and get to this part. I haven't done attendance yet either, so I'll go ahead and do that real quick.
I'm all set. Thank you.
Yep, you're welcome. No problem. Thanks for letting me know. I'll have everyone keep up here. Not a problem. They have a couple different options. You could always do default, but yeah, you can see that it's all nicely filled in and everything. It has these fields plus a few that I calculated field myself, like 10-day change and 30-day change, 90 and 200-day change in market cap. We can use some of those as features in the model that we're creating. So it's almost ready. Here's the preview. Go ahead and create. It's already a super clean data set. We got it from a REST API. So we won't probably have to worry too much about cleaning it up. And then why these have some missing values is just because of how long we have the history for. Is that we don't have a 200 or 90 or 30-day change because we don't have that many observations in the data set. Runs out of observations to calculate them. So super clean data set. All right, and we've done that. So let's go ahead and explore the data set next. So just part of like data understanding. So we understand the challenge. We're trying to predict overall market cap. Pretty straightforward. Explore the data set. Let's get a little bit of understanding of it. It's not too hard to understand this one from the columns, but something we would particularly do with data sets is go ahead and explore it a little bit. Okay, so we viewed its contents. Oh, I think they want us to go back here. So now within your project, if you go back to just project home, you'll keep track of everything. You'll see number of data sets, recipes, models, notebooks, dashboards that are created. One's automatically created for it. You can do that wiki. That was a nice one to be able to document a little bit about your model. And then you could go to your workflow. So what they want us to do here is explore the data set. You can click on data set. You'll see a view like this. If you click on it, you'll have an Explore tab. That's where it was at. Yeah, we were already in here. Check for missing values and outliers in key volumes like caps and volumes. Believe, so you can go to things like not just seeing the missing values, but you can quickly analyze them or sort values or change formatting or scientific notation, whatever you would want to do. But let's go ahead and click on Analyze. Then you can see the distribution of these to see if there are any outliers. That's huge in model building because outliers can have a huge influence on your performance of your model and your the coefficients in your model that you're using for prediction. Or just, so they call them high leverage observations. They can greatly influence the predictions if you have big outliers. So you have to figure out what you want to do with them. Yeah, so they have the counts of each one. Let's do a fuzzy cluster just to see how some of these come together. 185 possible clusters. Probably more useful on a calculation like cap percent change 10%. Something with more discrete values. It says no clusters found. And it didn't find any on them anyway. So yeah, I'll show, they're all pretty much unique values too, so, and spread out. The clustering doesn't help that much, but if you had a lot of repeating values, might be able to find some clusters in there, some similars. Socio, something like household income might cluster into a couple different clusters. And if I did whole data values to compute, you can create a bunch of, this is where clusters will probably help out more because you have multidimensional data. You can do a bunch of summary statistics if you do full data. So if we just did full sample statistics and save and compute. Let's see what we have here. Top 10 over 12. Yeah, that didn't really help us out that much either. All right, anyway, you can see that there are a number of ways that you can explore each. You can explore each variable accordingly. You can see the frequencies and distributions and outliers, which is hugely important in modeling. That may lead you to transform one of these columns if you see outliers or exclude some observations and so forth. It helps you with what you may need to do for the next step in data preparation for your model, for the data that you need for your model. Okay. Let's go back to our project home. We'll create a new recipe. To do that, we're going to need to create a new flow. So let's go ahead and go to our flow. Okay. So your flow, you see you have a bunch of visual recipes. You can even do things like insert Python or R code or PowerShell or use Spark for processing and so forth. It has all of those built in. It has Spark built in to Dataiku also. Oops. All right, so what we want to do is pull in the data set. So let's go ahead. That is the data set. It automatically does that for us. Ooh, can I zoom out? Maybe not yet. Zoom out. Yeah, well, I'll be able to zoom out once we start to add some more recipes to this workflow. So click on the data set in the flow, select visual recipes. Let's do a prepare, create recipe. So we have a new data preparation recipe. There's your input. And for it does each step, you'll have an input to it, and then you'll have your new data set that's outputted. That's really valuable to be able to see each transformation as it goes. And you could even store this in a Postgres database if you wanted. But we'll just keep storing it in CSV files. The data set's small enough. No big deal. Okay. Select create recipe. Okay. So we want to handle any missing values. You can create a processor and fill your empty cells. I'm just going to do this for example because the missing values that we have are valid. So let's just do it on this 200 cap change. So you hit that button there, the plus to add a new step. You do fill empty cells, data cleansing, maybe in data cleansing, or let's just type it in. Fill empty cells with a previous value. There are a number of ways that you can do. It's called imputation with filling in blank values. You could do the average of the column, or you could set them all to 0 or some value. You can even do regression if you wanted to try to estimate what those values would be. But let's just, for the sake of looking at this, fill them all with the fixed value. So the column that we want, I don't think I can just drag that over. Send cap change 200. Oop, nope, I don't want to do that step. That's just moving it in the data set, their order of the columns. Let's delete that step. Column cap. Just want to show you what this step will do. Let's fill those in with just -1 or -99. That's one of my favorites. Okay, let's go ahead and run this recipe. See what happens here. So on this data set, I don't believe it changes this data set. Oh no, it does. It does show the new data set that we've created. And you see all those missing values filled in with 99. Don't necessarily want to do that in this data set. Let's actually fill it in with the average. Let's see. Let's try to do that. So if we filled it in with the average, can I go back on this one? Maybe not. Let's delete it. If you delete it, it should go back to normal. So I'll keep applying each step. What's really nice about this is now you don't have to write code. You can just have these rules in a pipeline, and every time you have new data, and just go ahead and apply these rules. Okay. Extract with regular expression. Python function. Just trying to see how I'd connect in it. I would probably do a Python function. Produce a new cell for each row. Output column, error column. Oh, I see. You create a notebook here, and then it would apply it to that. So I don't really want to do that either. So let's go ahead and delete that step. We won't spend too much time on this. I just see if there's a way. Compute the mean of numerical numbers. So it wasn't in the cleaning. Is it in math and numbers? Compute the mean of numerical values. Column not specified. Okay. Input columns. Cap. Percent change 200. Oh, I see. Okay. Find an output value of no selected column. Okay. That doesn't actually quite look like it did it either, huh? Oh, well. Find a way to take a look. Probably do quick search to be able to do some mean imputation on the other ones. That's one of the things when you do this in modeling, if you have missing values, oftentimes your model won't accept that entire observation because of the missing value. So like these that have any missing value, some models are sensitive to that, and it won't include this observation at all. But it's okay for now. Or you could just choose zeros, but maybe perhaps that's not that accurate either. So let's keep doing these steps. Handle any missing values. Processors, fill empty cells. We already did that. Type conversion. Convert date to date format if needed. So yeah, one of the things is that these are all like some weird Unix timestamp, datetime timestamp that needed. And in my Excel sheet, I convert all of these to a date. I got the formula and did that. Let's see if we can convert these in any way. data cleansing. Let's see where this is at. Probably dates. Convert a Unix timestamp to a date. I want to say there's something that was even different than a Unix timestamp, but let's try to do that. Date. Well, that looks like it. Now looks like it worked. Output column date. Let's just call it date 2. Let's go from date to date 2. Let's run it. So check that out. We applied that filter, and it did put it in that format, actually. That's kind of neat. This is a date time, some type of Unix date time. I did an odd calculation in it, but you see how that's super valuable now to have that as a date time or a date. And we'll use these date column. We'll find a model that uses those dates in prediction for prediction. Okay, so let's go ahead and keep that one. Feature engineering, create a lag feature for market cap. So I did that with, well, I did chat the cap percent changes. So let's also create a lag, like 10-day, 30-day lag. So we can do processors. Lags can be useful for predictive purposes too, because sometimes there's a lag effect of some column, like change. Maybe it changed, dropped 20% one day, which has a impact on your market cap at some time in the future, perhaps. So never hurts to engineer these things. So we can do, it says it's process, it's a window calculation. Let's see if I can find it here. Processors, window. Am I missing it here? We'll just type in dough. Is it in reshaping? Actually, don't see it in here. Strings, filter data, group tails, extract numbers, again, bin numbers, which is often useful also to create some type of bin or group for prediction. Updates, geography, enrich. You can do join other data sets together. Just going through these as I look. Do some natural language cleaning and processing and tokenizing. Complex objects. So let's just go ahead and look this up real quick. I don't see it in here. How can I do in Dataiku? Moving. Was it a moving calculation? How can I do a lag calculation? Open your data set, choose window. I think it's it's not in the same data processor. I think it's another one of those cleaning recipes, or another one of those recipes. So let's go ahead and go back. Okay, so we can go back to our flow. see if I don't think that, I think it saves automatically. So let's go back to our flow if we can. Okay, job succeeded. I think it saves every time it runs. No, that's not working. So let's just go back to our project and then go back to the recipe. Recipes. Or can I see my whole entire flow? There we go. So if you go back up here where I was before, as inside of that recipe, and right here, you can go to that option. You see you have the different ones up here. You can write code, you can run your job and so forth. You can go back to flow. And now we have that cleaning step there. That prepared, and it created that new data set prepared so that we can continue to add on to it. All right. So if we go to this data, this step here, in here, I believe there'd be a window calculation or a lag calculation. Generate statistics. You can generate sample statistics. You can do a bunch of things. There's our window calculation. Okay. Do window. I didn't see it in the other one. Okay. So it's continues to make this bigger because it's a nice description of the steps that you have applied to that data set. Let's create a recipe. Okay. So apply to the cap column with lag is equal to 1. Okay. We'll just call this lag underscore 1. Oops. Let's see. So we want a window frame on. This frames allows you to limit the number of rows, taking into account compute aggregations. That's not what I want to do. So window definitions, okay. That's what it does. So we need to define our aggregation. So we don't have any partitioning columns. So partitioning column would be like if you have your data set sorted by state, you could say just do the calculation over state and then start at the first observation and go to the last. Your ordered column, we could turn that on. That's date. And maybe your window frame, you don't use the entire data set. You limit what your aggregate frame is. Okay. So compute aggregations, you can compute ranks, where you can do an aggregation. So this is just a lag aggregation. So we would do, it has the last value, what you can do like a last one, but we want to do market cap and then do a lag of 1, lag difference of 1. Market cap. Okay. See if we want to do any others. Maybe we just apply that 1 for now. You could apply multiple others too. Let's see what happens. Probably don't want to calculate an average. We do these separately. Windows. I think that we have to do them separately. Okay. Let's go ahead and run that. Let's view this data set to see if that lag variable was created. So lag 1 large cap, that means like for this value, it'd look at the previous day's value. So it lags 1 day. So the value created on 12/13, that I think that's per trillion, 1.1,939,000,000,000. And lost a little bit of precision there, interestingly enough. But it does get you the value for the previous day, the lagged value for the previous day. And then you could go 10, 100, how many ever lag days you needed. Okay. It could do moving average. Go back to do that. Your flow. You can keep adding on to this. Let's see, file system. Okay, prepared. Create that recipe. Let's do, it says do a 7 and 30 day moving window. No partitioning columns. So if you had a data set with multiple cryptocurrency coins, you could use a partitioning column of coin, and then it would just do that calculation for each one of the columns. Okay, let's go ahead and go to our aggregation. Let's do on market cap, average, the last 30 days. Value in a following row, lead difference. I think maybe that's not what I'm looking for. Lead. An average with a lead of 7. Retrieve original value in a following row. Okay. And before we do that, let's see if we can give this a name. And then you could go all the way back, filters, and so forth. Window description, aggregation. See if we have any more actions. We do not. Okay, lead difference. Trying to see if I could do 2 in the same calculation here. Okay. Let's move custom aggregations. Post filters so you could filter out afterwards. Maybe your sum is, you want to do it if it's less than a certain amount, filter amount. And then your output. So it'll give you a cap of a lead 7. Looks like you can only do, I only see where you can do 1 at a time. Advanced. It'd be nice if you could do more. Maybe there is a way to do that. We'll just go ahead and run. We'll just create that 7 day. I won't worry about the 30 day. And I try to get to some model building anyway. Okay. Okay, so now we have that variable, 7 day moving average. So this goes from 12/13 to and instead of lead, I wanted a lag. there instead of a lead 7. Because that would be the lead 7 would be the 7 days ahead of it. 2, 3, 4, 5, 6, including that day. And you see that there's no values for that. So I can go back and change it real quick. It's good to check the results. Let's change that from, it's a lag of 7. And instead it's an average and not just the value. So yeah, lead looks forward. You want the previous 7 for the moving average. Okay. Go ahead. I'm sure that worked fine. If not, you could go explore it. So it should be the other way around. I shouldn't have values for these first 6. Kappa lag 7. Kappa the average. Except, good thing I did check it because it looks like it doesn't do the moving calculation. All right. Okay, average. I probably have to click on that to apply it. The lag of 7. Cap 1, lag 1, cap lag of 7. Okay. So that seems better. 1939. Oh no, that's still just lag 7. All right, well, let's go ahead and not wrestle with that too much. We do need to create a target variable. So we need to predict the future cap. From that observation, we need a target that says this is what the date. So if we're predicting 7 days ahead, we need a target value that from this day, say, if you're on 12/13/2019, you say what was the future value in 7 days. So you would do, including this day, 1, 2, 3, 4, 5, 6. What was the value on 12/19? So we're using the value for them from that observation to predict the market cap 7 days ahead. So we need to do another one of these. Let's go ahead and go back. We can go back to our workflow. Let's do another window calculation. Okay. Create recipe, order columns. We have our date as our ordered column. Have our aggregation, so our cap. This one would actually be lead, looking into the future. That's a lead of 7. Let's go ahead and run that. This will be our target variable for our model. See if that worked. Weirdly enough, nope, that's right, because, okay. So for these at the bottom, we would not have that information because we don't have information for 5/9/2024. So it's actually this day and then plus 7 days. And then if this is right, this should be 7 days from 2013. So 1.8655 trillion. 1.8655 trillion. Okay, that calculation looks like it works. And so cap7 is going to be a target variable. Okay, save the prepared data set. So we can go back now into our flow. We could run the entire workflow now. We can start here. We can start at different actions, or you can go to the flow action and build all. You can build all the required dependencies. These could have different dependencies, and you could build all of them before you get to a certain point. These can get pretty complicated. This one's just a straightforward one. We're just doing each one in order. Okay. Went very fast. Okay, feature selection. So create an analyze recipe. Okay. So more actions. Oops. Let's open that back up. I think we can go up here and click analyze. Maybe not. Visual recipes, analyze. Summarize, analyze. So you can see other things like data quality. You can do those checks. Where is the analyze here? Summarize, those are LLMs. Just looking for it here. Feature clear. The flow, click on the prepared data set. Click visual recipes and analyze. I'm missing it here somewhere. So correlation analysis, let's type in correlation. No. Recipes. Creation, okay. That's not it either. So let's go ahead and look this up. Can't find it. Maybe I apply lab to it. Oh no, maybe I do explore. Statistical test, univariate. No. Let's go back to our flow. Okay, well, let's ask ChatGPT. Let's do how do I do correlation? And Dataiku flow. Statistics, visual analysis. Okay, so this give us better step-by-step. Okay, click on your data set in the flow. Get back to Dataiku. Okay, choose statistics from the right panel. Where are you? Generate statistics. There we go. Okay. In the pop-up, go to variables. Select 2 or more columns. That is not what I'm looking for either. Option 2, use a visual analysis. Click the data set. Visual analysis. I'm having a hard time with it. Not generate statistics. Okay, we're going to skip that part. So in generally, you want to explore the data set. And when you're creating a model, you usually don't want variables that are too highly correlated with each other because it impacts the precision, the reliability of your model estimates. We'll go ahead and skip that for now so we can keep moving forward. But how recipe? Oh, visual recipe. So down here, there are other recipes. So let's try that. Okay, let's give this a try one more time. Okay. Choose statistics from the right panel. Recipe. And generate statistics. I still don't see correlation. I don't see it. So we'll go ahead and keep moving. I'm going to get to the deployment part anyway. Okay, feature important. Let's run a quick ML analysis to see feature importance. Under machine learning, click quick model. So maybe this is no longer in flow. So let's go back. Oh, and lab analysis. Okay. So we need to go back here. It wasn't in all of this wasn't in our flow. I think it's actually in our analysis. So let's create analysis from the data set. So let's do this one after we created all the Windows calculations. So I did that. I went back to the main project area, and then there's something that's called experiment or analyze your data. So we can do new analysis name, analyze this. Okay. So under analysis, let's skip this part. Anyway, let's go ahead and create our first model. So I did that just to show one more time. So in your lab, if you go back to the main, we've created our flow and recipes. We created an analysis here, which should allow you to do some exploratory data analysis that we're having some trouble doing. But we could always look up, we could always look these things up. So let's go back and just go ahead and create this model. So we're going to go back to our home project, create a model. Okay. So it says save models. Okay. Deploy a model from visual analysis to a flow. You may create an ML flow model to benefit all the. So you can import ML flow models that you create in code or elsewhere. Also, if you create it in Azure or if you create it in Spark, you can import those. You can do a visual analysis and then create a custom model like we saw there. Or we can just create our own model. Okay, so we can create our own model. What are we going to call this model? Cap future 7-day future cap. And of like what our target's going to be. Prediction type. It's not two-class or multi-class classification. It's not classification. Could be another prediction, but this one's a regression one because your inputs are continuous variables and so is your output. So we can do a regression model here. Okay, you'll be able to create, once we do this, we'll be able to import data and experiment tracking and so forth. Okay. Okay. Okay, so add a model from Databricks. You could even create this here from Databricks. Actions. Let's go ahead and import a model or import that data set. Let's see, let's add actions. Create, evaluate. Probably what we want to do. So we want to evaluate, let's see, versions. We probably actually want to do that with ML model first. We want to create an initial model. Except this is asking me from Databricks. Is also not what I want to do. Okay, let's go back out of this, out of our project. Let's go our project and analysis. And if we go to project and analysis, there's create our first model. I guess in that other one, that's not what we didn't want to do the ML flow model or import it from somewhere else. We just want to create our own model from this data set. Okay, great. And we actually have we have different options now. Generally, it would be like a time series or regression model. You can do an auto ML prediction, different types of prediction or clustering or image classification. Let's do time series forecast. Okay. Create a model on select numerical feature, market cap. Select your date feature, which would be state overall. So we actually aren't using the target on this one. We're just going to do our other ones. And say we're just going to use our market cap and try to gain a pattern. And we're going to use time series to predict the next few of these out there. Let's go ahead and do some quick prototypes. I think that's what it's really asking us to do here. Do quick model. Okay. So target variable. Okay. So we have cap. Your time variable is read text settings. There we go. Your time variable, date overall. I didn't want it to be that one. Cancel. Okay, let's do nothing selected then. Do you want the variable to be cap? Time step is 7 days in the future. Forecast horizon is 10. So go every 7 days and it'll go 10 days into the future. Horizons and evaluation. This will show your historical data. So it'll be the next 70 days after the historical data. Okay. Train test settings. Okay, we don't have enough records for it to be an issue. We'll do mean absolute error for your model, for model evaluation, your model evaluation metric. You could apply different algorithms on it if you wanted. Very useful if very useful on machine learning models. Let's actually do an ARIMA on this one and see if there's any seasonality. Hyperparameters, you can do some sensitivity on it and some type of validation. There's your runtime environment. So this is all designed. Let's go ahead and train it and see what happens. Oops, no variable selected or time variable does not have date. So I guess we do need to go back to that. And I'm running out of time, so I need to get through this a little bit faster. Models. Okay, let's go back to the design. Choose date 2. Okay. Let's go ahead and train this model. I'm going to get through this faster. 2 models will be trained with 0 external features because it's a moving average model or a time series model. So you don't need any features. You actually just need that target. So maybe this one wasn't the best model to choose for what we're doing, but we'll just do a simple time series model. Don't need to activate GPU. Session name, time series, overall cap, time series. So we'll ignore the warning, we'll run anyway. It's running the model. Looks like it's doing 2 different types of models. Yeah, failed to train both of them. Of course. It says environment not found. That's what happens when I ignore that message. Oh man, okay. Let's create a new modeling task. Let's do something different. Let's do auto ML prediction. Okay. Create prediction model on that cap with the lead 7. So let's use that as a target variable. Quick prototype. Designing your model's been prepared. Let's just run it. Okay, it's going to give us an R² score. A sweet R² score there. So it's running these models. It may just go a couple minutes here overnight so that we can get all the way to deploying it. Okay. And what's nice is like it even shows here what the most important features are. So it's the moving average, the cap, and the lag of 1. So it's those features that we created. Okay. So let's go ahead, and it looks like this random forest one is the winner. We can go ahead and select that model. Go ahead and train. Okay. Review the importance of those. We reviewed the model, the importance of those. Okay. Create final feature set based on correlation and important analysis. Create a new preparation recipe. Let's go ahead and skip that. Let's just run this. Session name is ML Flow. ML Flow overall cap history 7-day prediction. Train it. Yeah. Save as crypto market features. So maybe this one is still running. Okay. So we have these models. Okay. Download. Okay, we'll do this random forest est one. We say that one's our best. Okay. Let's not worry about creating the final feature set. So step 4 is train a machine learning model, create a visual ML recipe. Go to recipe. Prediction. Let's go back to model, not model. Let's delete that one we did before. Visual ML. Okay. Let's go back here. Okay. Back to our model. Here was the design. Here's the result. Here are our models. We selected one of our models. And you can do a bunch of these and things. Okay. Actions charts. You can see the charts and everything. Performance. Okay. Agent tools, experiment tracking. Okay. So create the visual ML recipe, machine learning and prediction. Okay, let's go back to the flow then. So that was our lab to see which model works the best. So now we could do prediction on this data set. Prediction model, create a prediction model in the lab, then deploy it to the flow. Ah. We're going to do a prediction data set. So we must have just created a model. We're running out of time here. Actions. Trying to see how we deploy this model as the model that we want. Okay, from the visual ML recipe. So we're still on this part, feature selection, correlation, feature importance. Create a final feature set. Okay. Deploy script. Okay. I haven't run. Looks like I have run out of time building this model and trying to deploy it. Feature importance, create funnel feature set. Give it just one more minute here to see if we can figure this out. Two models will be trained on 11. No. Model comparisons. You could always create your models in your notebooks if you wanted to. I am just not finding it. There's our prediction data set. We don't need that. Hadoop and Spark. Flow actions. Yeah, you have generative AI. You can add. Let's see if we can add it one more time here. If we add a lab, okay. If you go back to the original and you go to lab, you can add an ML prediction. So really this up here is we were exploring the data. So we need to create a model within our flow. And then you have, this is where you say quick prototypes or high performance models or interpretable models. Let's just do an interpretable model, auto ML model. We'll just call this cap lead 7 model. Okay. All right, everyone, for going a couple minutes over like usual. Let's create this. You can train it now or review the design. Let's just train it. We should get a pretty similar model. Well, they're using different models here. Similar R-square, though. Looks like it ran already. High R-squared values. It looks at most important features to predict that 7-day forward total market cap. Okay, let's go ahead and train our data, train our models. So overall cap train. Go ahead and train this model. Okay, so we build our model. We're doing training and testing. Looks good. Okay. So then after we do that, did not appear there. But it is here, back in this ODA SA example. Okay. So now can add it, maybe add it to our flow. So if we go here and then we do prediction, still nothing. Oh, apologies everyone for not having the full work area. We got most of the way there, and then we're getting stuck here. So a little bit with trying to. We are training it. Okay, create click recipe. We did these ML models. Select the best model. Let's go ahead and try to select the best model. I think it did that. Let's get it. Train to decision tree. So we selected that model. Okay. Evaluate and select the best model. Okay, we trained it. Okay, select the performance and the results tab. Compare them. Feature importance, we see that. Select the best performing model, we did. Now to deploy the model from the model results, click deploy. Agent tools, wiki. Grade 7 model. I'm not sure if I click, see if we can deploy it from here. Deploy, okay. Oh, okay, so in our models that we've looked through, if you click that model, you can hit deploy. Okay, so it's our train data set. Our model name is predict cap 7 lead. We're going to deploy it. Now it shows up on our flow. Okay. You can create a scoring recipe to get your predictions. So that's predict cap 7 lead. Okay, from the flow view, click on the model, select score, select the data set, the score. Okay. So we really probably want that last one in the set, the one that we trained the data, trained it on. Okay. So that's where you could take out all the columns except the most important features to do it. We're just going to leave all of them in there. It shouldn't hurt the model. Let's see, at least for this purpose. So select score, select the data set to use. We've done that. Configure the score settings. I'm copying the whole input. Output explanations. Output model data. Let's do explanations anyway. So let's go ahead and run this to generate the predictions. Okay. Could view the details or run the explore it, and now we have some predictions here. We have our explanations. Looks like a JSON of the features that we used, and here's our prediction variable. Actually looks like close to a flat prediction, interestingly enough. Well, not flat, but it's flat over a certain time span, or for a lot of these. So that's probably some type of smooth prediction. Okay, create an API deployment from the flow view. Click on model. Okay. Click on the model, select API designer so we can create the API. So overall model predict endpoint ID. We'll just call it overall. Let's see, it should be given a unique, should be unique in a given service. Overall predict one. Okay. So now we're working, we have our model. We want to go ahead and deploy it. This is a model that we're using from the model page. Okay. We created it, set your input parameters. Don't need any enrichments. Could run a test query, create a test query on our API. You can create documentation for the API. Maybe you're releasing a bunch of endpoints like we've seen in the past. But let's just go ahead and it says create. We don't need any test queries. I'm going to go ahead and publish on developer. This is version 1. So the link to this API designer is not set. Oh, it looks like there's some configuration to be done. Go to the model page, publish actions. Can't just start the developer server. Okay, developer server is running. Publish on developer. Okay, open API deployer. The API designer. Oops. Now let's see. So we created that in the API designer. Go to the test tab. Okay, test queries. And there's sample values. So let's take just some of our values there. So we're testing our API. We're making sure this API service works by sending it some JSON in the body. Oh, it did work. Hooray. Oh, man, we got through it. Okay, so deploy, configure, and then we have some monitoring to do. But since I kept everyone an extra 15 minutes, I think we're going to call this a win. So that's how you deploy it. And then you have a few steps here where we could create model and create your model monitoring, set retraining, and then create a dashboard. I have a bunch of working exercises to re-record for everyone to help them out with the final project. I still haven't done it, but the plan is to do that. So I'll work on those and then this final part also to help everyone out with that final project. I'm sorry, everyone, for taking up extra time here. Let's see if we still have this live stream. Should still be going. Am I server? Oops. One second. Can everyone hear me? Ooh.
Yes.
Yeah, I can hear you.
I know I messed something up here. Hold on. Hey guys, can you still? Hold on. I did something where I'm in here a couple of times. Thanks, Christelle, for hanging in there with me. We're done for the night.
All right. Have a good night.
Okay. All right. So that's it for tonight's lecture. That actually concludes the lectures leading up to the class project. We'll have one more lecture on Monday, which includes additional topics of monitoring security, optimization, and security. along with real-time analytics, real-time streaming and processing in Microsoft Azure. They won't be a part of the class project, but they will be a part of the final exam and an understanding of what the technologies are and what use cases and when to use them. So that's it for tonight. Jeremy Bergman, the instructor. I will see you on Monday. Thanks, everyone.